I'm building a 2-trailer tiny house and it's been a while, but it's time for a build update. So let's check it out. So it's been a while since the last build update. And the reason for that is, firstly, there's been a lot of stuff that's been quite time consuming and honestly not that interesting till I get to a point where I can actually show you what I've done. But secondly, as I've moved into the interior, there's been this really big planning and prototyping stage where I've had to work out where everything's going to go, and because I'm automating so much stuff, how things are going to work so that I can actually provision those services, like my sliding door to the bathroom above me here, how that's going to work, but also then how the wall that separates the trailers is going to work and the cabinetry, etc. But more importantly, some of the ideas that I'm going to do inside his house are a little bit crazy. And because I'm putting those services through now, I'm kind of committing to those ideas. So I spent a lot of time in the workshop prototyping, working out if these things will work, or at the very least, working out the critical components of those to see if the idea is viable, so that when I'm putting the services and provisions in for, I know I can commit to them and I'm not going to have trouble down the road. But we're finally at a point now where pretty much all the services are roughed in and we can check it out. So the power in the house is going to be a mix of AC and DC. Now the AC is primarily just my power circuits and running my air conditioner. The rest is going to be in DC. And the reason I've done that is, first of all, I can do all the DC myself. And secondly, I'm going to be doing a lot of automation in the house, which is all low voltage DC. So instead of inverting my battery, so my battery bank is 24 volts, and instead of inverting that up to 240 volt AC, running it everywhere I need it, and then using transformers to step it down to the electronics, half of my stuff can run directly off 24 volt, and then the rest of it I can use high efficiency step down converters where I'm only just stepping down that 24 volts to the voltage that I need, which is a lot more efficient than stepping up and down again. Now it's really important to note, if you are running your own DC, while it is safe, it can be dangerous in the sense of you're dealing with much higher currents, and also with low voltage you can get voltage drop. So the cables end up being much heavier. If you are doing your own, there's a ton of online calculators where you can put in the length of the cable, the current that you're going to be drawing, and the voltage, and it can help you work out what cable you need. So keep that in mind if you're doing your own DC, just to make sure you're speccing cables correctly so that you don't damage something or end up turning your tiny house into a crispy tiny house. So the side trailer has sort of become the main trailer that houses most of the services, and this is where I'll be generating my power. So I'm going to have the batteries outside of my house, and then I've got 4 50mm square cables bringing the battery power up into my inverter. The inverter will then feed the power up to the main switchboard in the side trailer here, where it distributes to the circuits in the side trailer, and also sends a circuit out to the other trailer where it can hook into. Now the interesting thing about the 2 trailers, even though this is a single house, it'll never be disconnected, it's always going to be together. They are 2 trailers, so I've technically had to wire them independently, which kind of sucks because it means it's double the cost on all my switchgear. So I've got my switchboard here that's distributing the circuits and then sends out to an outlet underneath the trailer where the main trailer here will actually plug into, and then brings power into its own switchboard here where it's going to distribute power around the trailer. So that kind of sucked a little bit. Now my batteries are going to be housed outside of the trailer, and the reason for that is battery technology is changing pretty quickly and becoming much cheaper. And by the time I get to replacing my current battery setup, chances are I could be going with something different. So instead of locking myself in with building them into the cabinetry here, I put them outside of the house. In fact, I'll probably build a battery box into the drawbar of the main trailer, which also makes it a bit easier for me to deal with the batteries and manage ventilation as well. So I'm automating quite a bit of stuff in the house, and the approach I've taken to that is sort of a hub and spoke model where I've got 2 automation hubs that sit in the house. I've got one that'll be in the cupboards up above the kitchen, and another that will sit in the wardrobe in the bedroom there. And each of those hubs will sort of be, one will be a central point, and another will be that controls stuff throughout the trailer. So anything that can be simply switched will be brought back into here. So the actuators for my swinging walls, the floor lifter, LED lights, fans, etc. will all be brought back into here and switched centrally. Anything that's more complex, all I've done is distributed power to it. So like my air vents here where they're going to have drive motors. There'll be a controller here that's going to control the drive motor, manage the state of the window, etc. I've just brought the power out to it, and that'll hook back into the automation via Wi-Fi. So I've distributed power to the end of the trailer here. So I've got my air vents and some lights. I've got some power here where there'll be a control panel, maybe. I've got power up above the shower and my services hatch. So there's going to be quite a bit up here controlling ventilation, my composting toilet, fans, a shower, which I'll explain in a moment, and also some sensors. So I've just distributed power up to there. Also then around here in the bedroom, I've got the air vent and chargers in the bedside tables and some lamps and stuff. I've brought power down to there as well. And then, of course, the hub that we see in the bedroom here, which is going to control switching of the lights, fans, and probably some of the automation around the air conditioner. So the plumbing in the house is pretty standard and straightforward. Well, with one exception I'll explain in a moment. So the main trailer is where the water is going to come in. This captures water, so there's going to be a rainwater tank off of this trailer, and the rainwater pump will go down underneath here. So the main water comes in here and then feeds the sink and then heads off to the side trailer there, where it goes to hot water servicing and bring hot water back into this trailer. Now, this is all pretty straightforward with one exception. If you look at the outlets to my sink, I have 3. So to explain that third outlet, in fact, it's an inlet, I probably need to explain my shower. So if you follow along on Instagram, you may have seen when I posed the question about where do I place my tap in the shower. I really wanted the tap in the center there. It's this super minimal shower with a recess and then this single brass tap. If we ignore regulation, just the function of that, like you kind of have to reach around the water or reach through it, which isn't ideal. And the only other option was to put it off to the side here, which I didn't like because it's sort of like this dicky tap off the side. And everyone was like, no, function over form, put it offside, don't put it there. And I didn't really like that reality, so I decided to create my own. I'm like, what if I didn't need a tap? And I came up with this harebrained idea of automating my shower and just doing away with the tap altogether, which is a little bit crazy. And you can see there are no provisions for a tap in here. So this is one of the crazy ideas I've been working on, and I had this shower thought, and I was quite literally in the shower, and I was waiting for the water to heat up, and I thought, man, there's just so much water that's just going down the drain. I wonder if I could save that. And you know, when you're off grid, rainwater is pretty precious, and this summer I've almost run out, so it's sort of something I've been aware of. And I thought, if I've automated my shower, the shower knows when it's up to temperature, so arguably I could divert that water back into the rainwater tank. And so on top of automating my shower, I'm kind of making a water recirculation system, which will preheat the shower, and while it's doing that, divert the cold water that's coming through the pipes back into the rainwater tank. So that's why I put a third pipe in here so that I can recirculate the water back through the rainwater tank. Now, it seemed maybe a bit inconsequential, but I did the sums and it probably could save me a couple thousand litres a year, which isn't huge, but when you're relying solely on rainwater, that's actually pretty handy. So I figured if I can create the technology for the shower, I then have the technology where I can also preheat the water that's coming through to my kitchen. So if I want, I can push a button to preheat it, it's recirculating water back into the tank. I know when it's hot, I can turn the tap on, I've got instant hot water. It's a little bit crazy, but I kind of like the idea, and I've figured even if I can't make it work, it hasn't cost me much to put an extra pipe in. So out here on the outside of the house, I've got my gas hot water. Now this thing was a bit of a pain in the butt. One of the things I didn't think through with this cladding was how I was going to attach appliances to it, because I can't put anything flat up against it. So what I had to do was to put some timber studs on the inside, put bolts through, and then make up this frame with some custom brackets in behind here so that I could bolt on the hot water service and it sits over the top of the cladding nice and neat. And also, just in case it ever has to be replaced, it's not too hard to switch that over. So this hasn't been hooked up yet because still waiting on the plumber to have a look at gas. We're trying to work out if one trailer can hook up to the other with a bayonet fitting, or if they have to run separate gas bottles, sort of the same as that electrical problem. So he's talking to the technical regulator about that. But hopefully soon we can hook up the gas to that, and we'll bring the water pipes out as well, so that can be all hooked up. So the water comes into the house via this connection here. This is where my rainwater pump will hook onto. It then goes through a sediment and then a carbon filter. and I've got my outlet there for my rainwater pump. You also notice here that I haven't put a fitting onto yet. This is where my water recirculation is going to come out. So I'll be able to hook a hose onto here that will come back into the tank and recirculate the water. Then the services for these two trailers need to join together somehow. Now, that was a little bit of work because while the electrical isn't too bad, as long as the cables are supported, they're pretty easy to route across to the other trailer. But I also need to run water pipes as well. In fact, I'm running almost 7 different services between these two trailers. I've got 240 volt AC, DC, solar, hot water, cold water, water circulation, and if the gas can connect between these two trailers, then gas as well. So what I've done is created a services tray that slides out from the main trailer and hooks onto the side trailer. So I can lift the tray out, slide it out, and I've got these cable chains so the cables run smoothly as I pull it out and hook it onto the other trailer. I can then take these leads, plug them in, and then run my water pipes in here as well. So on the side trailer here, we've got all the outlets and inlets that allow me to connect the services between the two trailers and bring services in. So off to the side, I've got an AC input, which allows me to connect a generator to my solar system, or either grid connector and bring AC in. I've then got my water recirculation outlet. So a garden hose fitting will go into there, which then goes off over to the main trailer, and from the main trailer back into the water tank. And then I've got my hot and cold connection. So the challenge with hot and cold was I needed to be able to connect flexible pipes between the two trailers that could handle pressure and temperature. So I managed to find flexible hose that I've got inside here and then wrapped in lagging, and then these cam lock connectors. Now the beauty of these cam lock connectors is they're tool free and a really good connection. So I can take my dust cap off, and the other beauty of them is I can put dust caps on them for transport. And then all I need to do is to push on my hose and then pull these cam locks around. Now, the beauty of them is those cam locks compress the nipple up against that rubber in there. That rubber is easy to replace, but also creates a really positive connection there. And these guys have a really high pressure rating, so they should give me a really good connection between the hoses without creating any issues. Next, I've got my battery inlets. So I've used dual Anderson connectors. Now I don't like Anderson connectors because they're only a spring-loaded terminal and you're dealing with pretty high current. So what I've done is I've used 2 Anderson connectors and polarized them. So I have got 2 different connectors here, which means I can't reverse polarity my batteries, and I'm using both terminals per polarity. And then I've got dual 50mm cables coming off of each one going off to my inverter, and the same will come off to my batteries. So this allows me to house my batteries down here underneath the trailer. Then over to the other side here, we've got the AC. So I've got an auxiliary which allows me to take it use it as an outdoor power point or go off to a workshop. I've got the other AC outlet which the main trailer plugs into. I've then got my solar inputs here, so there'll be an array on the main trailer that plugs into this, and then an array on a ground which will plug into that. And then I've got my Anderson connector here, which takes the 24 volt DC across to the main trailer. The only thing that's missing is potentially a gas bayonet connector, and that will sit here. So we'll have to find out if we can connect the main trailer into the side trailer here to take off gas that goes off the cooktop, or if I have to do separate bottles on each one. That's the plumbing and electrical pretty much all roughed in. The next step's get an answer on that gas, get that installed, hook up a hot water service and run a gas line through here into the kitchen for the cooktop. I'm also moving on to the air conditioning and ventilation, which you may have noticed in this video is already well underway. In fact, I've probably only got a couple things to do on that aircon. I can get that commissioned and do another video. And I'm pretty excited to share that with you because the air conditioning in this place is going to be pretty cool. Pun intended. No, what I've done with the air conditioning is really cool. It's more than just your average split system. So I'm pretty pumped to get that done and share what I've done with the air conditioning. You guys know the drill. Don't hate, educate. Comment down below if you see something in this video that can be improved or you've got any questions about what we talked about. If you're one of the crazy people still watching, show us those 2 hands in the comments. In the meantime, go build cool stuff. I'll see you again soon.